All right, hello everyone. Thank you for joining us. We will get started in just a minute. I'm going to give everyone about another minute to go ahead and join us, and we will broadcast here shortly. If you would like, you're welcome to enter into the chat a quick hello to everyone. If you want to let us know where you are joining us from, or if you are a SLU alum, or a water or environment professional, or just someone who loves water, please go ahead and put that into the chat, and then we'll get started with the program here in about 1 minute. All right, everyone, thank you so much for being here. We are so excited to have you join us today. We will go ahead and begin. My name is Rachel Rimmerman, and I am the Business and Outreach Director for the Water Institute here at St. Louis University. Just to share a little bit about myself too, I am also a co-advisor for the student group Billikens for Clean Water. So I work with that student group's international team, and we've been partnering with students with communities in Belize on some clean water situations that they need help with in some communities there. I'm also a PhD student in the Public and Social Policy program with a research focus on water policy. So I have a long history of working with water, and I have a deep passion for these issues, and it's so exciting and such an honor to be involved with the Water Institute in this new initiative that SLU has in this area. So I'm so excited to be here sharing our 1-year anniversary of our public launch with you all, and thank you for taking the time to join us today. Just a couple of quick announcements before we get going. There are a few features on AirMeet that I want to point out in case you are new to the platform. It's a pretty fun virtual platform. As many of you have been using, there's a chat feature. Feel free to give a shout out. Let us know where you're chiming in from. We'd love to know who all is here with us today. And then there's also the Q&A window, which is just next to the chats window. If you have any questions throughout the presentation, please go ahead and enter your questions there, and we'll do our best to get to as many of those as we can at the end of the event. There will be some dedicated time for Q&A. The other quick thing I will note, and I'll put this into the chat as well, there is closed captioning available for anyone who would find that helpful. You just need to click on the little box that says CC underneath the speaker windows. So that is another great feature of this platform. All right, so I hope you enjoy this program. We have our leadership team here to share some thoughts with you today, as well as a couple of our students who are doing incredible research, and we also are excited to give you a sneak peek of our labs. And then at the end, of course, we'll have question and answer time, and then we will leave the virtual lounge open for a little while for anyone who wants to stick around for some virtual networking. So that being said, let's go ahead and get to it. And I would like to introduce the director of the Water Institute, Dr. Amanda Cox, who will kick off the event for us with an overview of the Institute.
Good afternoon, and thank you for so much for celebrating this afternoon with us for our birthday. Thank you, Rachel, for that great introduction. As Rachel said, I am the director of the Water Institute. I'm also an associate professor of civil engineering at St. Louis University. My expertise is in the field of hydraulic engineering, and my work revolves around the flow and movement of sediment and water. This includes areas like river engineering, stream restoration, and urban drainage. I was drawn to this area mostly because as an undergraduate, I was studying several areas, and I really enjoyed the topic of fluid mechanics, and I found it to be quite challenging and exciting. And I also just really enjoy being around water. So as a hydraulic engineer, I'm able to use those fluid mechanics principles to study and design environments with flowing water. So it's really quite exciting for me because I enjoy those two so much. So we know that water is fundamental. As humans, we depend on it, and our communities and societies are built around water and constantly interacting with and impacted by water. Yet our water faces still critical and persistent challenges. These include climate change. It is affecting our water supply and long-term security, as well as impacting aquatic species and entire ecosystems. Another area is increased human activity. It's putting more stress on our water resources and leading to increased pollution of those resources. We're also dealing with aging infrastructure and how it's affecting the way we access and interact with water, leading to issues with water quality, water security, flooding, bridge and levee safety, and so on. There are so many critical issues that we have that are related to water. These problems are local and global, and they don't affect everyone equally. Vulnerable populations and underrepresented communities are more heavily burdened by these water issues. So there's a huge equity component to water and environmental work, as well as the science and engineering and other challenges. So we know these problems exist, and we also know that at St. Louis University, we have incredible experts, tools, resources, faculty, students, and we decided to do something to address these challenges. And so we created the Water Access, Technology, Environment, and Resources Institute, or the Water Institute, with the mission of water innovation to serve humanity. The water innovation piece of our mission is to lead interdisciplinary, collaborative research and to find innovative approaches and solutions to our most pressing water challenges. The Water Institute is based on three interconnected pillars. First is water in the built environment. This includes areas like infrastructure. It has a strong connection to engineering. The second being protecting aquatic ecosystems, strongly connected to the fields of biology, geology, water quality. And then the last pillar is social justice. And our structure also recognizes that these three aspects, the built environment, the natural environment, and the social environment, are all interconnected and interact with each other. So naturally, in recognizing this, our work is interdisciplinary, and it brings together faculty experts and student researchers from across the university and beyond our campus. We have a team of 8 primary investigators who are faculty in the areas of civil and environmental engineering, earth and atmospheric sciences, biology, and public health. These faculty are really steering our collaborative research projects. In addition to the primary investigators, we have 18 associated investigators from areas such as law to chemistry to urban planning. Our associated investigators include faculty at SLU, as well as researchers from other institutions institutions such as American Water, SIUE, and the National Great Rivers Research and Education Center. And this team continues to grow. And of course, we have over 30 undergraduate and graduate students who are critical members of our research teams, and they're from a number of different programs as well. So with all these incredible researchers, we are engaging with collaborative projects and focusing on how we can find new, innovative approaches and solutions to water problems. So the other piece of our mission is to serve humanity, which aligns very well with SLU's Jesuit and social justice mission. At the Water Institute, this piece focuses on using our expertise, research, and tools to serve our local and global communities. We do this in a number of ways, sometimes in very practical ways. For example, I serve as a volunteer scientist for the community of DeSoto. This community has been experiencing increased frequency and intensity of flooding, so this is something that impacts us here locally. We also advise and support student groups like Billikens for Clean Water, who are partnering with communities in Belize to help find solutions for clean, safe water access in their families' homes. Another way we serve our communities is by hosting events and providing platforms for bringing together experts, sharing knowledge, and building connections across sectors to continue to grow a water community. Our goal is to grow into a regional hub for water conversations and connections, to make meaningful contributions to water, working with many nonprofit and environmental groups and the work that they're doing. And many of those folks are on here with us today. We also want to provide ways to bring these great leaders and organizations together so we can continue to have innovative approaches to water problems. And last, but certainly not least, we look toward the service piece of our mission by training the next generation of leaders in water and environmental fields. We truly believe in the power of our students to go out and change the world, and we're proud to be a part of their journey. You'll hear from a couple of them very soon today. But first, we want to share something else with you. Our new interdisciplinary lab space. This new lab space at St. Louis University was provided by St. Louis University and the Office of the Vice President for Research, and they have generously supported the Water Institute with over 3,600 square feet of custom designed collaborative lab space. And this new space is in the new interdisciplinary science and engineering building on our campus. And this space was provided to really support the mission of the Institute. And here to share more about our new space with you is our lab technician, Sofie Liang.
Hi everyone, my name is Sofie. I'm the new lab technician in the Water Institute. I joined the team this January, so it's been amazing 4 or 5 months for me to working here. My role is basically operating and maintaining instruments, and also I take care of students' safety and lab behaviors. So my role is more like a supporting role, which is also my strength. So I'm really excited and also honored to be able to work here with all the amazing people with their great researchers. Thanks.
Welcome to Water Institute. Okay, let's start with our instrument room. So this is our our instrument room. We have the Q-top, and there is another instrument by the corner. It's another LC instrument. This instrument helps us to measure the water quality in our natural versus synthetic water samples, and it helps us to detect what organic compounds in our water and measure the amount of these compounds. That's your clean room. So now we have Dr. Liz Miller's samples and Dr. Craig Adams' samples stored in there, and we still have a lot more spaces for the future samples. Summer is one of our PhD students. She is the one that's working on this instrument majorly, and she is going to talk to us a little about her research.
So what I'll be using the Q-top for is calculating or detecting some cyanotoxins after we run them in the other lab for treatment with oxidants. So it's cyanotoxin oxidation, and see how much oxidation we can get out of it using the typical oxidants in water treatment plants and then advanced oxidation processes. And we're going to use the LC-MS Q-top for our concentration to detect whether there's anything there, and it's a powerful instrument. So we're excited. Okay, cyanotoxins are the toxins produced by cyanobacteria. And cyanobacteria is what we commonly would call blue-green algae. They're not really algae, but they come around and they bloom mostly in the summertime over lakes and reservoirs and the surface water. And they're causing quite a few problems across the world, and it's increasing with climate change. So we're targeting that because water treatment plants use these surface waters for to make our drinking water, and we need to make sure that they're clean and no toxins in them and clear.
So here you see we have more spaces that we are planning to build our lab with more powerful instruments that will empower our institute to help other students to do whatever treatment or measurements they want to do in this lab. Next, let's go into our wet chemistry lab.
So we do water treatment research here. We explore different treatment techniques that can describe taste motor compounds and cyanotoxins, which my colleagues in R does. And this is our lab.
Hello, welcome to our hydraulics lab. So in this lab, instead of water quality, we care more about water quantity and the movement in the natural water system.
This is the stream table. We use it to understand formation of streams and rivers and analyze how they're forming and evolving.
Okay, thanks for joining us for our virtual lab tour. We hope to see you here in person.
All right, great. Thank you, Sofie. Sofie will be back with everyone at the end of the event for the Q&A. So if you have any questions about the lab, please go ahead and put those into the Q&A section on the right-hand side of the platform. Or if you have any questions for Amanda, go ahead and drop those in there as well, and they'll join us here at the end. I did see that it was a little bit hard for the video to be heard when folks were talking, so I apologize for that, and we'll go ahead and share that video link in our follow-up email in case anyone wants to go back and listen to that again. All right, so next, I'm excited to introduce two of our outstanding students to share what they have been working on with you, Carly Finnegan and Natalie Hernandez. And we'll go ahead and start with Carly.
Hello, thank you, Rachel. So as Rachel said, my name is Carly. I'm one of the graduate students here at St. Louis University. I'm in the Department of Earth and Atmospheric Sciences, and specifically in an environmental geochemistry graduate program. And so I'm about to start my third year here as a grad student at SLU. I recently finished my master's, and now I'm continuing on to a PhD. And so I study water because for me, water resources have always kind of been at the forefront of my mind. I grew up in the Great Lakes state up in Michigan, and up there it just seems like always in the news, or whether it's in the newspaper at your local news, you're hearing about different water quality and water quantity issues. And so growing up kind of being in water all the time and hearing about all these water issues, it just kind of motivated me to want to continue studying water and keep going with understanding water quality and quantity issues. So now I'm going to share some of my master's research. Okay. And so now we'll get going. So the focus of my research was investigating if these organic compounds, synthetic organic compounds that are present in laundry detergents and paper products called optical brighteners could more reliably be used to identify wastewater entering streams than traditional wastewater tracers, such as E. coli. And so the motivation behind this is because, untreated wastewater can potentially enter streams through things like aging infrastructure that eventually starts leaking, or faulty septic systems, or intentional or unintentional sewage releases. And that untreated wastewater that enters the stream has the potential of threatening human and aquatic health because it contains pathogens, emerging contaminants, toxic metals, and fecal waste, to name some things. And human exposure to these recreational waters that have been contaminated by untreated wastewater are linked with an increased risk of infections in humans. And so water managers want to find a tracer that they can use in the field to track wastewater leaks and contamination in real time. And so traditional tracers that are used for wastewater contamination are usually expensive. They cannot be used in the field, and so they require you to take samples back to a lab, are highly technical, or they could be from multiple sources. So they could be indicative of either wastewater pollution in the stream or drinking water pollution in the stream. And so optical brighteners are emerging as a wastewater tracer to quickly identify contamination in the field. So optical brighteners, as I said before, are these synthetic organic compounds that are in detergents and paper products and are used to whiten and brighten. So if you go check your laundry detergent bottle and it says makes your clothes 2 times brighter or 5 times whiter, that's because of the presence of optical brighteners in there. And so optical brighteners are emerging as this tracer because you can use a handheld field fluorimeter, like what's seen here, to detect the amount of optical brighteners in the stream in less than 1 minute. And they aren't from any natural sources, so you know that they're from either paper products or detergents or any types of soaps. And so my study was completed in the Fishpot Creek watershed. And so the Fishpot Creek watershed is this residential watershed located near Valley Park or Manchester, Missouri, for those that are interested or familiar with the area. So here's the state of Missouri, St. Louis City, St. Louis County, and Fishpot Creek in relation to it. And so we completed samplings at 26 sites every month, which are shown in this map here. And then we also did a weekly sampling every single week at the bridge site shown in this image here. Oops, sorry, that clicked. And then once we collected the samples, we did both in the field and in lab analysis for various water quality parameters or chemical and biological analysis. Now I'll just show you some brief results of what we found. So we saw that optical brighteners were elevated in areas with high infrastructure density. And so here in this western portion of the watershed, we have higher average amounts of optical brighteners from our monthly samplings. And that's the same area where we have this concentrated area of high sewer pipe density. And so when we used a model to figure out how much wastewater could potentially be in the water at those sites, we saw a positive correlation between sewer pipe density and the percentage of wastewater, indicating that wastewater may be entering the stream through faulty or leaking pipes. We also found that optical brighteners and E. coli have a positive correlation. And E. coli is a bacterium found in the gut and in fecal waste of warm-blooded animals. And so we see this positive correlation. However, it is weak because E. coli can be from multiple sources. So E. coli can be from humans, but it can also be from deer or other wildlife, or even domesticated pets like dogs. And so if you have a dog park next to the stream and there's a large rain event, that could wash some of these E. coli bacterium into the stream. And so that would be non-human contamination. And so in conclusion, our data indicate that some wastewater may be entering the stream from infrastructure leaks. We also found that optical brighteners are a better indicator of wastewater contamination than E. coli and some of the other traditional tracers that are used, like chemical constituents like boron and fluoride. And then we kind of came with the conclusion that streams that have high optical brighteners should be further investigated to protect both human and aquatic health. And so thank you for your time and for listening in on my research. Next up, Natalie Hernandez, another graduate student here at SLU and is a part of the Water Institute, will talk about herself and her research projects.
Thank you, Carly. So like Carly said, my name is Natalie, and I'm a second-year PhD student in the Hassenmuller Environmental Geochemistry Lab studying microplastic transport. And so the reason I really love studying water is how it fosters connections. I grew up in the Mississippi, or along the Mississippi River in Memphis. And so here in St. Louis, I feel really connected to my hometown because of that, even with the research I'm doing in the Mississippi River watershed. And on top of connections from place to place, I feel like it also connects all of us through our shared need for water resources. So those are some reasons that I really enjoy studying water. And essentially my project is just looking at some aspects of this connection and the movement of contaminants from place to place. So I'll share screen to give a bit of an overview. Okay, so the overarching topic for my research is microplastic transport in urban streams. And this is my study site, which is Deer Creek here in St. Louis. So microplastics are small pieces of plastic, and they can come from a variety of sources, such as larger plastic litter that can be in the watershed, like here it is at my study site. And when this is in the watershed, it could be continually breaking down into these small plastic pieces that are then transported in the water. It can also come from sources like textiles. So this figure on the left is from a study looking at different types of clothing that we wear that has synthetic fibers and how those can make these smaller fibers that then get out into the environment. There's also other sources, but these are a couple that we see at Deer Creek. Like I said, we see examples of litter in the watershed, unfortunately. And then also in some environmental samples I've looked at, we've seen fibers that might indicate that these are coming from something like clothing that we wear. So these are a couple ways that microplastics end up in watersheds like Deer Creek. And the reason that we want to study microplastics is based on the potential for ecological impacts, because small creatures living in the stream can consume these because they're in such a small size. And also these microplastics can accumulate over time. And as we're continuing to use more and more plastic societally, we're kind of worried long-term about what the consequences are of these microplastics just being generated continually. So the visible plastic litter at Deer Creek is one thing that makes it a good study site, but another thing is just its proximity to St. Louis. So you can see this map on the left shows that the watershed, which is outlined in white here, of my study site is in a very highly developed area. So that means it's prone to higher sources of plastic potentially from the urban impacts it faces. It also has higher impervious surfaces like bridges and roads that cause increased runoff and sometimes flash flooding, along with impacts by urbanization. The study site also feeds into the Mississippi River through the River des Peres watershed. So this is an example of those connections I was talking about, where you can see in this inset map how my study site here is connected to more places downstream and eventually to the ocean through the Mississippi River. So I really appreciate how that gives kind of broader implications for the work I'm doing. And then I showed that picture on the last slide that had some examples of pavement and things. This is just another image of some of the urban impacts that Deer Creek faces, unfortunately, but that makes it a good study site. And you can even see some plastic litter in this photo also. So to study microplastics in this system, right now I'm looking at water samples primarily. And so we collect water samples to analyze for microplastics, and also take samples for other geochemical tracers like optical brighteners, which Carly was talking about. You can use those to trace wastewater, as she discussed. So that can be a way of identifying a potential source of microplastics to this stream through wastewater that might have microfibers from our washing machine effluent and things like that. And we also do some other geochemical tracers just to identify sources of water and also potential sources of plastic pollution into the streams. So with the microplastics water samples, we filter those and end up with filters that look like this, which we can then put under the microscope and inspect for microplastics. And that's how we end up with images like this. And there was another one I showed you on a previous slide. So that's kind of a general overview of the flow of microplastics research for processing water samples. So as I'm continuing to analyze water samples at Deer Creek, I'm also starting to collect other samples that I plan to analyze, such as stream sediment samples to see differences between microplastic content in water and sediment, and also storm samples. So this auto sampler can be used to sample throughout a storm event, and then we can see how microplastic concentrations change during it. Because storm events can transport large quantities of water, especially in urban systems, and also potentially large quantities of plastic. And then lastly, I'll also be sampling biota like clams and mussels to look at, again, comparisons between sediment, water, and then microplastics in these living creatures. So each of these projects will hopefully help me determine how microplastics are moving within the system at Deer Creek, but also potential transport downstream. So thanks everyone for listening, and Carly and I will both be in the Q&A later, so please stick around if you have any questions.
Great. Thank you so much, Natalie and Carly. Those were great presentations and a great overview of the research that you all do, and really an example of the amazing students that we have. So thanks so much for joining us today. Next, I would like to introduce our Associate Director, Liz Hasenmuller, who will share a few final thoughts about our vision for the Water Institute And after that, we'll hop into the Q&A. So please remember to continue to put any questions you have in the Q&A panel there on the right. And I will hand it off to Dr. Hasenmuller.
Hi, everyone. So thank you, Rachel, for the introduction. And as Rachel mentioned, I'm Dr. Liz Hasenmuller. I'm an associate director of the Water Institute, and I'm also an associate professor of Earth and Atmospheric Sciences in the College of Arts and Sciences. So my research expertise is on critical zone science. And for those of you who are not familiar with critical zone science, the critical zone is basically the zone that goes from the tops of the trees down to the base of the groundwater and looks at the dynamic interactions of different systems in that shallow portion of the Earth's surface. So that would be the air interacting with living things, interacting with water, interacting with soils, and interacting with rocks. And so one of the things that links together all of the different components that I just spoke about is water. So water is moving through the critical zone, is providing nutrients to plants, it's moving weathering materials into the groundwater. And so this is a fundamental thing that links all of these different aspects together. And that's one of the reasons I'm really excited about water, is because you can look at these dynamic relationships among different components of the Earth's surface. And my particular expertise is based in basically water quality and understanding how humans impact the critical zone through transporting things like contaminants. So you heard a couple of my graduate students talking about their work, looking at how these contaminants move through the critical zone. So this is my background and kind of why I love water and what brought me into this field. And as the Associate Director of the Water Institute, what my job is to oversee the research operations of the Institute. So as the team members have shared today, we have a lot of things going on, and we're really excited about what we've been doing, but also where we're headed with the Water Institute. And so we're very excited to be having our first birthday and looking forward into the future for all the things that we're wanting to do. So as we continue to grow this collaborative research effort at the Water Institute, we have some targeted areas that we really want to build capacity. And so some of those areas include climate change and environmental sustainability. So we're trying to create expertise in building tools and models to get a better and deeper understanding of the effects that climate change have on the environment and what kind of environmental stressors we have on our water resources. We're also keenly interested in understanding agricultural impacts on water resources and how water interacts in agricultural systems. So we're very much hoping to build expertise in soil science. We also have a great group who do things with urban water quality, but we'd like to build that capacity as well and get into more watershed modeling. And then we're really well positioned to move forward in all of these areas because we're in a location that's really uniquely positioned. So we're sitting at the confluence of the two largest rivers in North America. And we also have a range of different environments that we can look at and understand water-related processes. So we're here in St. Louis, situated in an urban setting, but we also have agricultural systems very close by it, as well as more natural forested ecosystems close to the city as well. So the final thing I wanted to mention in terms of research areas that we're really trying to develop is a field called complex adaptive systems. And so this takes a systems approach where we're connecting different pieces together. So science and engineering, but also aspects of economics and social justice, and looking at how all of these different components interface and are connected by water. And the way that we're wanting to explore this is through processes like machine learning and artificial intelligence. And so this is another area that we're really hoping to build expertise for the Water Institute. So we want to continue to create research capacity, both through field efforts and lab efforts by building up our high capacity instrumentation. So Sofie showed all of you some of the instruments that we have in the ISD building currently, but we'd like to be building this capacity more so we can continue to do this really cutting edge research in water related fields. And so we of course also want to continue to have support for our students and create additional opportunities for them to have hands-on research experience in the field of water. And all of these goals that I've mentioned really are moving us forward in our mission to use water and water innovation to serve humanity. So there's a lot of work that we've already accomplished. We're very much excited to be at our first birthday, but we have a lot more to do in terms of protecting water resources. And we're really excited about our future and the coming year and years coming up for the Water Institute. So on that thought, I'm going to hand it back to Rachel, and she's going to introduce the question and answer portion of the session.
Great. Thank you so much, Liz. So as the rest of our speakers go ahead and rejoin us here for the question and answer period, I just want to chime into her last point that it's really exciting and an honor to be a part of this work right here in St. Louis and with St. Louis University as we work towards creating really impactful change as to how we research and understand and approach water issues in our society. And it really exemplifies SLU's commitment to environmental sustainability and the future of environmental sustainability. And so with that, it really includes and encompasses the entire SLU community, which really is all of you as well. So there's a role everyone can play. We hope everyone joins us on our mission as we continue to grow with the Water Institute. So we're going to go ahead and move into the question and answer period. We have a couple of questions here for Carly and Natalie. Before I jump into that, I will also remind you all, if you want to go ahead and type the questions into the Q&A, that would be great. We'll also have a function called raised hand. So you should be able to see on the right hand of your screen where you're able to raise your hand. And if you want to do that, what that will allow us to do is pass you the mic so that your video can actually be brought on stage right alongside the panelists and our team. So if you would like to be a little more interactive, you are welcome to do that. You are also welcome to type them in as well. So with that, I will go ahead and ask Carly first. Are there any TMDLs within the watershed around St. Louis County that target the pollutants you're studying, or any other regulations dictating target levels?
Yeah, that was a great question. So part of why the Fishpot Creek watershed was chosen was because it has a TMDL, or total maximum daily load, created for it for E. coli and chloride contamination of the watershed. And so while there aren't TMDLs for optical brighteners, since optical brighteners are present in detergents, or they're present, they get into the stream when people wash their cars and then it gets down in the drain, and other paper products, so like toilet paper, it comes from those. It's a good indicator of where wastewater pollution can be happening. And so we kind of used a TMDL for Fishpot Creek and targeted that watershed as the study of interest for the optical brighteners testing to see how it compared to like the TMDLs that were already created for it.
Awesome. Thanks, Natalie. And then, thanks, Carly. And then the next question, the same question, is for Natalie in regards to microplastics.
Yeah, so good question. And I'm reading the Q&A, and your point is correct that a lot isn't known about microplastics in terms of knowing enough to be able to have a TMDL. So no, there isn't one, and there aren't regulations, at least in Missouri or pretty much anywhere in the US, although California is the first state that is going to be developing regulations. So for the last, I believe, 4 years, they've been working towards doing more research to be able to figure out how to regulate microplastics. But there's a lot of standardization essentially that's needed to be able to know what we're seeing out there, because it is a newer field, and how we may or may not be able to regulate them. Yeah, so hopefully my research can help a little bit by answering some questions, and someday maybe we can have regulations. Thanks.
Great. Thanks so much, Natalie. Are there any other questions? Let me go ahead and check here. Thank you, Mr. Canning, for those questions. Really appreciate those. All right. There's a question here from Cheryl Sullivan that is probably for Amanda or Liz. Does the Water Institute have any projects looking into water governance?
I'll answer this one. Not that I'm aware of. Liz may know of some that have some specific water governance, but I'm not aware of any that are looking at that right now. I'm trying to think. We have a lot of different projects, and it could possibly be a component of a few of them, but not that I'm aware of. Liz, are you familiar with any projects that I might be missing?
No, I
maybe
can't.
we have some around climate change and some other aspects that could have a component about water governance, but I'm not that familiar enough with those projects to speak to that.
Yeah, similar. I can think of a few projects that may have some facets for the governance aspect, but not any specifically based on that topic alone.
Okay, great. Thank you for that question. Okay, so I have another question here that was sent to me in the messages. You had mentioned some projects related to climate change and climate change modeling. Would you be able to share a few more details about what the Water Institute is doing in those regards?
Yeah, I'll try to address those. So the two main projects, actually there's about three projects that I can think of. And one is by Dr. Jason Knopf, and he's been studying climate change, I believe, in the Mississippi River Basin and projecting conditions into the future. And I can't tell you all specific details, but say 50 years plus into the future, and looking at how climate change is impacting flows in our rivers and sediment in our rivers, as well as river temperature, and then ultimately impacting those ecosystems and the species that live in that environment. So that's one example. I believe that's an NSF-funded project. Hydroclimb, it's called Hydroclimb, yeah. I have another project that I'm working with the Army Corps of Engineers, and we're developing a modeling tool, a numerical modeling tool that will project out changes in river size and shape, basically just river changes over several decades, over 50 or 100 years as well. And so as we know, rivers are just constantly changing based on how much precipitation we get and other factors in the watershed, how the watershed is developed, and in different ways that we manage different areas, like management of reservoirs. Anyway, there's a variety of things that impact how rivers change over time. And so we are developing this sort of innovative tool that brings together sort of physics-based models with more rules-based system to have some of the more complex changes that rivers can go through. So things like channel widening or changes in the sinuosity of a channel. I won't get too technical, but it's a really cool tool, and it's will enable people that are managers or watershed managers, planners, to get an idea of how the likely scenarios for the future conditions. So we look at a variety of different scenarios based on different projections of climate and flows in the channel and other things that might change within a water system. And we're able to sort of anticipate what the most likely scenario is and how different changes in the system could sort of guide the river to a more preferred solution. And of course, one of the things that we're investigating is climate change and the impact on that, projecting towards the future. Liz, did you have any other examples that maybe I might have missed?
I think you covered most of them, but Jason Knopf, one of our PIs, has had multiple projects looking at climate change and how that impacts temperatures and different types of ecosystems and what potential impacts that could have on aquatic life. And so he's looked at some detailed modeling in smaller watersheds in the Missouri area, but has also done these larger scale models that Amanda mentioned called HydroClimb, which is funded by the National Science Foundation, where he's been looking at projecting climate change in these hydrologic systems many years into the future, 100 years or something like that into the future.
Great, thank you so much. Our next question is from Kelly O'Brien. Can anyone speak to the Water Institute's global water projects, such as in Belize? So I'd be happy to chime in on that one. And then if anyone has anything to add, definitely please do. So I've been working with Billikens for Clean Water's international team. Billikens for Clean Water is a student group. Their faculty advisor is also one of our PIs named Dr. Craig Adams, who's one of our, a member of our leadership team as well, and one of our civil engineering experts specifically in environmental and chemical engineering. And so we have been working with Belize for a few years. SLU actually has quite a bit of partners and work going on in Belize because of the Jesuit province. So the St. Louis Jesuit province is the same as Belize. And so there's actually a lot of great partnerships going on with the college in Belize City and with different organizations in Belize as well. And so what we have done up until the pandemic, of course, we haven't traveled since that, and we are hopeful that it will be safe to travel again soon. But we work with students that are trained here at SLU on campus in water testing, field testing. And we go to Belize, and we have actually spent probably the first 3 trips or so there, really just learning and listening and getting to know the communities in southern Belize, which is in the Toledo district. And ultimately partnered with one community that needed household safe drinking water capabilities. So they were drinking water directly from either the stream or from the well that was in their community, but that we had tested and came back with different coliforms present. So it was not safe water to drink. So we worked with the community, provided our thoughts on what we thought different technology options would be, and worked with community leaders. They formed a community water council. It was a very much a partnership. So it wasn't Billikens for Clean Water, the Water Institute going to Belize and saying, this is what you need. It was very much listening and learning from each other and trying to figure out what would be the best solution for their situation. And so the government is working on slowly going around all these different rural communities to install community-wide water systems. And this particular community is on the list, so to speak, to get a full system within a few years. But they really needed something immediately because the health of their kids was being affected by drinking the water that they were drinking. And so we worked with them to identify using the Life Straw community filters, but providing one for each house. And so the Billikens students fundraised for those, as well as the community leaders set basically a buy-in price for each household as well. And we worked with those community leaders and with the community as a whole to install one of those filters in each of the houses and train the families and the water council on their use and maintenance so that they would be able to have clean drinking water within their homes. So we continue that partnership. We've checked in a few times with our partners in Belize, both within the community and different organizations. We also work with the local government rural development office there. And again, hope to get back there soon. There's also another student group called Engineers Without Borders that works with another one of our PIs, Dr. Ronaldo Luna, and they have been working with an orphanage in Africa that needs a water system specifically for that organization. So they have been working on advising there as well. And those are the 2 main international projects that I know of. We do have public health faculty on our primary investigator team that is also working in Puerto Rico, which of course is part of the United States, but has some different water experiences there as well. And so So there's some different work going on outside of the contiguous United States. I don't know if Amanda or Liz want to share anything else. Okay, great. We'll take about one more question here, and then we will stick around in the lounge. So there are some outstanding questions. So if you want to come meet us in the virtual lounge after this, we will have a chance, hopefully, to answer some of these questions. The next question is, are there any plans at the Water Institute to study potential water quality, water quantity benefits of green stormwater infrastructure?
I think that falls under my purview, so I'll address that. We don't have any specific plans currently. It's definitely something that we have studied in the past, or our researchers have studied in the past. We don't have any current projects, but so we definitely have capabilities to study that. I know that's a really critical issue here in the St. Louis region with our combined sewer systems. And so we're currently not working on any specific green stormwater infrastructure projects, but recognize that it's very important to our communities and have that capability.
Great, thanks so much. Liz, did you have anything to add there?
Sure. Yeah, as Amanda mentioned, there's not current projects in this area, but previously my group has researched the water quality and how that's improved because of this type of infrastructure. And so there's, certainly interest and capability, but not current active projects in this field.
Okay, great. Awesome. Thank you for those answers. Thanks to everyone who's joining us today. So what we're going to do now is conclude the formal programming and move into the virtual lounge. So before we do that, for anyone who is not interested in joining us in the lounge, I just want to thank you again for joining us today. We're so excited to have had you here for our anniversary of our first public launch. It's always exciting to meet new people and see some of our partners and stakeholders through these events. So thank you so much for your time today. We hope you'll continue to stay in touch with us. Like we've talked about, there is a lot of exciting and urgent work to do. So we hope that all of you will join us in this work. So for those of you staying on, what we'll do now is I'm going to end the broadcast and it will take us back to that virtual lounge. And you can continue to chat with each other via the text in the chats or the messages if you would like. But you are welcome to join us at one of the tables, and you can do that just by clicking on one of the chairs at the tables. Our water team that you see up here will be split among some of the tables. So for some of those outstanding questions you have, please come visit us at the tables and we can continue those conversations. If you want to just come say hi, we would love to see you for just saying hello as well. And then there's also a couple of meetup tables. If you're an alum and you want to meet other alums, or if you are a water environment professional and you want to see who else is here in that space, or if you want to join the open table and just meet and mingle with anyone and everyone, please go ahead and utilize all of those. So thank you again for joining us, and we will see you in the lounge.